Consider the equation y equals x squared take 7x plus 12. Now what we want to do is find the x-intercepts for this given equation. And we can achieve this by converting from the general form it is in now into the intercept form. So let's do that. We write the following template, y equals, and then we're going to write x and leave some space and another x. And we need to find factors of 12 that make -7. And so in this case, -3 and -4 will work, as -3 multiplied by -4 make +12, and -3 plus -4 make -7. And so we have successfully converted from the general to the intercept form. And now the x-intercepts are quite trivial, where we'll have one at 3, 0 and the other at 4, 0. Now consider the equation y equals x squared plus x take 7. And now you can see here that we can't convert this equation into the intercept form, as there's no factors of -7 that sum to make 1. And so we need to find a different method in order to get the x-intercepts for this given quadratic relationship. And the way we can do this is by doing a method called completing the square, which converts from the general form into the turning point form. So the way we do this is by writing the following template. So we'll have y equals, and everything associated with an x on the right hand side of the equation is going to be put into brackets. So we'll have the x squared plus the x, and we're going to leave a bit of a space here and then write the rest of our equation. And our aim here inside the brackets is to add a value that would turn this expression into a perfect square binomial. And what a perfect square binomial is, it is in the form of x plus p squared, which expands out into x squared plus 2px plus p squared. And now you can see here by matching our expression, we have the x squared term and we have an x term, but we don't have this p squared term. But the way we can find this p squared term is by matching our x term. As you can see, 2p will equal our coefficient in front of the x. And so if we write onto the right hand side here, we'll have an expression 2p is equal to our coefficient in front of the x, which is 1 in this case. And so rearranging for p, we get p is equal to 1/2. And then if we square p to get our constant out the front, we get p squared equals to 1/4. And so now we have this p squared value, which we can add into our brackets to turn this expression into a perfect square binomial. So we'll have a plus 1/4 here, but notice that we've added a value to this expression, and so we need to subtract the same value in order to not change the equation. So we take the same value outside of the brackets, and now we can simplify. And so the expression inside the brackets can factorize into this form here, x plus p all squared. And so we'll have x plus p, and p in this case we solve to be 1/2. So we'll have 1/2 all squared. And then we're subtracting, when we have -7 take 1/4, which we'll do to the side. So we have -7 can be rewritten into a fraction of 28/4. And then we're subtracting 1/4, which is in turn going to give us -29/4. And so we have this value out the front, -29/4. And now you can see here that we have successfully converted from the general form into the turning point form. And now to find the x-intercepts, we just make y equal to 0. So we have, let's just rewrite it. 1/2 squared take 29/4. And we'll take the -29/4 to the other side of the equation. So we get 29/4 equals x plus 1/2 all squared. And now by square rooting both sides, we get x plus 1/2 is equal to plus and take the square root of 29/4. And now if we rub out the right hand side to leave some room, we're going to have to solve for x, we're going to subtract a half to the other side. So we get x equals plus and take the square root of 29 over 4, which can simplify into the square root of 29 divided by the square root of 4, which is just 2. And then we got take a half. And so our two x-intercept values is going to be at, one is going to be at positive 29 over 2, take a half, and another is going to be at negative square root of 29 over 2 minus a half. And so rewriting our coordinates, we will have one x-intercept at root 29 over 2, take a half, comma 0, and another one at negative square root of 29 over 2, take a half, comma 0. So to quickly summarize, we had this quadratic relationship here, which was not easily converted into the intercept form. And so we converted it into the turning point form by a method called completing the square in order to find the x-intercept values. And now we're going to go on to one more example where there's going to be a coefficient in front of the x squared, and we're going to complete the square to find the x-intercept values. Now consider the equation y equals 2x squared take 4x plus 5. Now what we want to do is find the x-intercept values for this given quadratic relationship, and we want to do this by completing the square. And what differs from our previous example is now we have a coefficient other than 1 in front of our x squared. And so the way we deal with this is we divide both sides of our equation by this coefficient, which is 2 in this case. So let's do this. So we have to divide the left-hand side by 2 and also the right-hand side by 2. So we have 2 divided by 2 is just going to be 1. So we get 1x squared. Take 4 divided by 2 is going to be 2x plus 5 over 2. And now notice we have a coefficient of 1 in front of the x squared. And now the exact same process is applied from our previous example to complete the square for this problem. So let's put it into the following template where we're going to put everything associated with an x inside brackets and then leave a little bit of a space and then add the rest of our equation on. And to rewrite our perfect square binomial expression, we have x plus p squared, and this expands out into x squared plus 2px plus p squared. And by matching our coefficient in front of the x with these two expressions, we can find our value of p. So in this case, we got negative 2 as our coefficient. And so we have 2p equals to negative 2. And then dividing both sides by 2, we get p is equal to negative 1. And so we have this p value equal to negative 1. And therefore, if we square p, we get p squared is equal to positive 1. And so our p squared value, our constant that comes out the front, is going to be 1. And now this expression can simplify into a perfect square binomial. And because we have added a value into our expression, we have to take the same value out. So we subtract 1 outside the brackets, and now we can simplify. So we get y divided by 2 is equal to, now this expression simplifies into the form x plus p squared. So we have x plus, and p was negative 1, so we'll have x take 1 squared, and then we have plus 5 over 2 take 1. So let's do that to the side. We have 5 over 2 take 1, which can be rewritten as 2 over 2, and this is going to be 5 take 2, which is going to be 3 over 2. And so we have plus 3 over 2. And now to finish our equation off, we times this 2 over to the right hand side of the equation, and we get the following turning point form. So we get y equals 2x take 1 squared plus 3, as 2 multiplied by 3 over 2 is going to give us 3. And so this is our turning point form. So now we want to solve for our x-intercept values. So let's rub out the right hand side here to leave some room. And we're going to rewrite our turning point form with y equal to 0. So we have 0 equals 2x take 1 squared plus 3. And we can start solving for the x-intercepts by taking the 3 over to the other side. So we have negative 3 equals to 2x take 1 squared. And we can also divide by 2. So this 2 will be eliminated and we'll have a negative 3 over 2 on the left-hand side of the equation. And if we square root both sides, we have plus and take the square root of this negative 3 over 2 is equal to x take 1. And notice here that we're square rooting by a negative number. And whenever we square root by a negative number, we're going to yield no real solutions for x. Or in other words, we're going to have no x-intercepts for our given quadratic relationship. Now let's quickly do a rough sketch of this quadratic relationship in the turning point form to get an idea of how it has no x-intercepts. So let's rub out this right-hand side here. And let's quickly draw our xy plane in. So we're going to have an x-axis here. And our y-axis is going to be up here. And so if we look at our turning point form, you can see that we have our turning point is going to be at B, C. And in this case, B is going to be 1 and C is going to be 3. So our turning point will be at 1, 3. So let's label these coordinates in our xy plane. So we go across 1 and up 3. So the coordinates of our turning point will be right here. And this is at 1, 3. And now you can see by looking at our a value, it is a positive value. And so we're going to have a concave up shaped parabola. So our parabola is going to look something like this, where it is a concave up shape and its turning point is at 1, 3. And now you can see that the curve never touches the x-axis, therefore has no turning points. So the way we found that mathematically is by getting the square root of a negative number. So that concludes this example, and now let's move on to one more example where we're going to complete the square on the general case. So now consider the general case, y equals ax squared plus bx plus c. And we want to convert this general form into the turning point form by completing the square. And so starting with our coefficient in front of the x squared, we need to convert this into 1. So we're going to divide both sides of the equation by a. So we get y over a on the left-hand side, and we get x squared plus b over a x plus c over a. And we're going to write our following template that we're familiar with from the previous two examples, and we get y over a equals x squared plus b over a x, and leave a space, and then write the rest of our equation. And now we want to convert whatever's inside the brackets into a perfect square binomial. So rewriting that general statement up here, we get x plus p squared is our perfect square binomial, and this expands into x squared plus 2px plus p squared. And so by matching the coefficient in front of the x, we get an equation 2p from here equals b over a. And rearranging for p, we get p equals b over 2a. And we want to find this p squared term. So let's square p, and we get b squared over 4a squared. And so we can add that inside our brackets here to create a perfect square binomial. So we get b squared over 4a squared. And so we don't change the equation, we need to subtract the same term. So we get b squared over 4a squared outside the brackets. And now we can simplify. So we get y divided by a equals, and this simplifies into our perfect square binomial in the form of x plus p squared. So we get x plus p, which was b over 2a. And we're going to square it. And then we get plus c divided by a, take our b squared over 4a squared. And now we want to isolate the y on the left-hand side of the equation, so we need to times the a over to the other side. So we get y equals a x plus b over 2a squared plus c over a multiplied by a, which we're left with c. Take b squared over 4a squared multiplied by a, one of the a's cancel out, and we're left with b squared over 4a. And so this is our turning point form when we're given the general form. And so now if we have the a, b, and c values for the general form and we plug it into this formula here and simplify, we will have the turning point form for our quadratic relationship. And so that's going to conclude this video where we have investigated how to complete the square, which is a method of converting from the general form into the turning point form. And in the next video, we're going to investigate the quadratic formula.